Good morning, all of you. Welcome to welcome to chemistry class. So today we are going to discuss a small topic and another very important topic of electronic displacement methods. Among them, first one is important thing that is nothing but inductive effect. Everything is important. Actually, four methods are there. So basing on those four methods, so the first one is inductive method and very simple, but it can explain a lot of uh, stabilities, a lot of compounds stabilities. So that's why we are going to discuss the inductive effect today. So one of the small and important method. Okay, so let's see that inductive effect and its applications also. So first of all, what is inductive effect? So inductive effect is nothing but, so organic compounds, all organic compounds should be covalent compounds only, right? So covalent compounds contain sigma bond and pi bonds. So generally, inductive effect can be happen because of migration of the sigma electrons towards the electronegative element. Okay. For example, I'm going to take a simple example for this. Let's take CH3, CH2, CH2, CH2. I'm going to take one halogen because halogens are highly electronegative. Let's take a chlorine. So chlorine is a more electronegative. So that's why these two electrons movement or migrate towards the more electronegative atom Cl. So what happened here? Somewhat electron density can be decreased, right? So that's why these two electrons are moved towards the CH2, as well as these also can be moved to the CH2, and same thing. So in that case, it will get the partially negative and it will get partially positive. And what about this one? This is also can get the partially positive, but less charge when compared to first carbon atom. So you can more partial like this. Yeah. So here what is happening? See, nothing, actually very simple one. Because of the charges, because of the charger means, this is called effective. Okay, it's an effect of inductive effect it is called, right? So very simple thing. So what are the characteristics of this inductive effect? So why we have this? So because of this inductive effect, we can say the stability of carbocations, stability of carbanions, acidic strength as well as basic strength, and also we can discuss the reactivity of alkyl halides. Okay, it's a very simple. So now see the next one. So characteristics. We can do, first of all, definition. We should write the definition. So definition is nothing but the migration of sigma electrons sigma electrons towards, or you can say migration of the covalent bond towards the more electronegative atom. More electronegative atom is called inductive effect. Simple. So because of this migration, okay, because of this migration, ions can be formed, right? Partially positive, partially negative charges can be formed. So these partially positive or partially negative are complete ions, maybe carbocations, carbanions, those are intermediates, right? So whether those intermediates are strong means stable or not, by using this method or this inductive effect, we can decide the stability of those carbocations and carbanions also, and we can explain, actually we can explain the why those are stable, right? Yeah. So now see, uh, we have some characteristics. Yes. So characteristics of Inductive effect. Characteristics of inductive effect. So generally we have some characteristics, means what is this type of effect and all we discuss. So characteristics are nothing but, first one, it is a permanent effect. So this is a permanent effect, not a temporary effect. A permanent effect in the sense it is always the effect should be there because of the sorry, because of the electronegative atom is present in that compound. So that's why the effect is permanent. Okay. Second one is partial migration. Partial migration of sigma electrons. Sigma electrons. So here only partial migration, not complete migration. Okay. But during reactions, in the reactions, so whenever the bond breaks, so intermediates can be formed. Those intermediate stability we can explain. Okay, why those are those are stable. By using the inductive effect we can explain that. So okay, so migration of sigma, a partial migration, that means, for example, let's take this one, CH3 and Cl. So only partial migration, because these two electrons are somewhat nearer to the chlorine because of the more electronegativity than carbon. Okay, so that's why it is getting partially negative and it is getting positive. So that's it. And the third one is only sigma bond involved in this effect. In this effect, only sigma bond involved in this effect, and we can say that is not only saturated. That means this is not the meaning of not only saturated. We can, it can be operated in the both saturated as well as unsaturated, because unsaturated hydrocarbons also contain sigma bonds. Okay, so the fourth one is this can be operated in both the saturated and unsaturated hydrocarbons. This is the fourth one. Okay, and one more important point here, it is you should remember this very important point, as the increasing of chain, as the increasing of the chain, so this effect is decreases. That means this effect can be seen up to 3 or 4 carbon atoms only. Carbon atoms only up to 3 or 4 bonds, covalent bonds, we can say that. So now what is this? I'm going to explain. Actually, in the first only I have explained this. See, only up to 3 or 4 carbon atoms only. If one more CH3 is there, so it cannot be, it's a negligible effect, very negligible effect, and sometimes it cannot show also. Maximum case only 3 atoms we can say, but somewhat very less effect can be happen on 4th carbon also. So that is the meaning of this 6 characteristics. And one after that, this effect is depends on, means, whatever the applications are there, we can discuss by using the two groups. Actually, so in this carbon compounds, so, this one, so we have two types of groups. One is minus IE groups and plus IE groups. So minus IE, what are the minus IE groups and what are plus IE groups? Are nothing but, electrophiles and nucleophiles. Electron rich elements, electron poor elements, like that we can say. So okay, we can discuss what are minus IE groups. Actually this effect depends on the nature of the IE groups. Okay, groups in the sense maybe the atoms. So first of all we can discuss the minus IE groups. So what are minus IE groups? So minus IE groups are nothing but these are also called as electron withdrawing group. Electron withdrawing group means in the compound the substance which is have more electronegative than hydrogen or carbon. So that can take away the electrons. That can take away the electrons from that compound. Okay, so that is why we can say that is called as a minus I group. We can say simply the group which is attached to carbon compound which is having more electronegative than hydrogen is called minus IE group. Here these are also called as electron withdrawing group. EWG means electron withdrawing group. Okay, one of the most important word this is electron withdrawing group and electron donating group. So what is that electron withdrawing groups and what are those, and how and also we can say that decreasing order of the electron withdrawing group capacity, that means strength. The first one will come NF3 plus. So NF3 plus is the strongest electron withdrawing group. It can take the electrons. So why it is, so we can discuss later. So after that NR3 plus NH3 plus NO2 cyanide CN and CHO COR COOH COCl CO and H2 amide group greater than fluorine, chlorine, bromine, iodine and OR, OH and H2 group and pH group, CH double bond CH2 group allied greater than hydrogen last one. So these are the, you can see this is a order of you should remember this order, the order of the elements electron withdrawing group which is having the more strength to attract the electron, take away the electrons from the compounds. So here NF3 2, you see total I think it is 20 elements are there, it is easy to remember. So from NF3 to you can easy to remember like this, NF3 to here CN, there are total 5 are there, all are belongs to the nitrogen groups. Okay, nitrogen groups like that, NF3 NR3 NH3 and O2 CN, like that you can remember. After that carbon groups you should see CHO COR COOH COCl CONH2. Next halogens 4 and next 6 are miscellaneous, you can easy to remember OR OH and H2 and pH allyl CH double bond CH2 and H, you can remember like that. So in this way you can you can group the all these elements, you can remember like a group wise. Okay, 5 5 5, okay, 5 5 4 5, sorry 6, 5 5 4 6, like that you can remember easily. And here why NF3 is highest, or has a more capacity. So let's see the structure of NF3. Fluorine, fluorine and fluorine. Here plus is there, right? It is already unstable because of plus. But and also one more thing is there. So these all fluorine atoms are take the electrons because fluorine is more electronegative than nitrogen. Actually fluorine has 4.0 electronegativity, 4.0 electronegativity, and nitrogen has almost 3.0 like chlorine, 3.0 electronegativity. You see it is more electronegative, so that's why these three fluorines take the electrons from the nitrogen, always taking the electrons from the nitrogen, and the charge of the positive charge is more increases. So that's why the nitrogen is very keen to attract the electrons towards itself. So that is the reason here these are highest minus Ia group, we can say that. And also here fluorochlorine carbon, so everything can be in the same manner. You can write these things in the same manner, right? I hope you can understand. So NR3 also, and R3 and H3, compared to NR3 and NH3, and R3 is more minus Ia group than NH3. Okay, right? NH3 plus, nana, sorry, NH3 plus, right? So next NO2. NO2 is also more Ie group. Remember this is NO2 because nitro group is so many times we can see in examples of nitro groups, and CHO, COOH both are there. Here let's take the CHO group once. Actually COOH has two oxygens, but I'm sorry, but CHO has only one oxygen, right? Let's take this double bond O, H you can take, or H you can take. So you see here, generally what happened, oxygen is more electronegative, that's why the sigma electrons are attracted towards the oxygen. So that's why it wants some, because it can get the electrons. Carbon is more electronegative here. Carbon is almost carbon is having 2.5 electronegativity, and hydrogen is having 2.1 electronegativity, means zero point 0.4 times more than that. So that's why it can attract the electrons towards itself. Coming to the C double bond O, OH. Actually two oxygens are there, right? Two oxygens are there. So what happened, generally we can think about that to here these electrons attracted towards the oxygen, and these also attracted towards the oxygen, right? Because of oxygen is more electronegative, because oxygen electronegativity is almost 2.8, it is there. So sorry 3.5, I'm sorry, 3.5. Okay, oxygen electronegativity is oxygen is equal to 3.5 electronegativity, and carbon is only 2.5 electronegativity, so it can attract, we know that. But what is happening here, why COH shouldn't come before the CHO? CHO came before that because whenever these electrons are attracted towards the oxygen, here this oxygen is ready to give the electrons to the carbon. So here somewhat it can be compensated with this oxygen. Okay, because here some electrons are losing by because of the attraction of oxygen. So that's why this oxygen is giving the electrons. So that's why this is less minus I group than the CHO. So I hope you all understand. And coming to the FCl, you know that fluorine is more electronegative than chlorine, and like that, and OR and OH also. So the same thing, OR and OH. Let's take OR. OR is CH3 can take, right? CH3, right? And here OH, OH, right? Here electronegativity of, you know that oxygen electronegativity is 3.5, carbon electronegativity is 2.1. So here oxygen is equal to 3.5, hydrogen is equal to, I'm sorry, carbon is 2.5, so this is 2.1. Okay, so what is the difference between here? 1, almost 1 is there, and here it is 1.4. 1.4 is there, it is 1. So 1 difference is 1, and here 1.4 difference. We know that oxygen is more electronegative, that's why the electrons should be attracted towards the oxygen, right? So then it has to come first. But here O and CH3 group is there. Okay, it is attracted by a one it can attract the electrons with a difference of one electronegativity. And here, okay, okay, right. So next, my plus IE groups. So coming to the plus IE groups. So what are the plus IE groups? Right. So what are the plus IA groups? Okay. See now plus IA groups. What is the meaning of plus IA group? Plus IA group nothing but the groups which are donating the electrons. Donating electrons are called plus IE groups. It's a very simple. So for example, let's take that. Uh, yes, CH3, C and CH3, CH3 is there. Let's take, for example, tertiary carbon. So here, CH3 has a capacity to give the electrons. It cannot, CH3 can't take the electrons. CH3 has a capacity to give the electrons. So these are called as we can say plus IA groups. Here this is a tertiary carbon, carbon. You can take, for example, here you can take hydrogen. Okay, tertiary or so this is nothing but tertiary carbon or secondary it will come. Okay, see this is the tertiary one, tertiary carbons. This is tertiary carbon, my students, and here three groups are giving groups are there. So greater strength than CH3C, CH3H. This is secondary, and CH3, CH2, primary, CH3. So the normal methyl group. Okay, so these are the plus IE groups. Yes. So actually, this is simple plus IE and minus IE groups, and going to that, so you have to know some important points in this IE. IE means inductive effect. So what are those important points? So these important points are nothing but first one, stability is always indirectly proportional to magnitude of magnitude of the charge, either it is plus or minus magnitude of the charge. Okay, so the second point is minus IE groups increases the charge on cations by attracting the electrons, attracting the electrons, attracting the electrons. So stability of cation decreases. Okay, decreases the charge on cations, charge on cations by attracting the electrons, so stability of cation decreases completely, right? This, another point is same, this minus IE group decreases the charge on anions, charge on anions by attracting the electrons, stability of anion increases. So we can say that carbocations or cation stability is indirectly proportional to minus IE, and directly carbon ions or anion stability is directly proportional to minus IE group. Okay, and fourth point in this one is coming to the plus I groups. So plus IE groups decreases the actually charge in the sense magnitude of charge. Okay, decreases the magnitude of charge, or just take the charge on cations by giving electrons, giving electrons. So stability of cation increases, stability of cation increases. Okay, it's a very simple thing, and I'm going to take another pen for this. These important points: decreases the charge on cations by giving electrons, so stability of cation increases. Okay, so next, fifth point. So plus IE groups increases the charge on anions by giving electrons, so stability of anion decreases. So the charge of anions, so anions is stability decreases. So finally we can say this. Okay, we can discuss the remaining part in the next video. Okay, so in that video I'm going to discuss the applications of this inductive effect, and the applications are also very important, my dear students. Okay, please check, and thank you for watching this video. Bye, have a nice day.